Everyone, how you guys doing today? Moving on in the next chapter, which is chapter 7. Yeah, iteration and search. So we went through a lot of basic stuff. We were introduced to just super brief, super quick overview of the chapter so far. Chapter 1, it's just some basic introductions to assignments and like types and things like that. Um, in chapter 2 we saw the difference between statements and expressions. Statements are executions, expressions are evaluated. um, and it's both. Usually if you're executing a statement, you're also evaluating some sort of expression, not necessarily always. Like for example, if you're doing an assignment statement, you're just assigning something, there's nothing to be evaluated there necessarily if you're just assigning something, right? um, we got into functions and interfaces, where we talked about the distinction between interface and implementation, which is important to think about and separate conceptually now, uh, because it makes things easier later on when you actually implement an interface. Conditionals and recursion, just your basic if else's and recursion. A function can call itself. Simple but very important topic to understand, even if not necessarily widely used in production systems. And return value is just the fact that functions give things back, right? And to be careful how it does that, right? Some talk about like silent bugs, wherein like if you have return statements nested in conditionals, you could just have some sort of case where you miss a conditional, and so a return type is none, which is not expected, and which is not expected, things like that. So let's get into chapter 7, iteration and search. Let's just run this first cell as we normally do. Iteration and search. In 1939, Ernest Vincent Wright published 50,000 word novel called Gatsby that does not contain the letter E. Since E is the most common letter in English, writing even a few words without using it is difficult. To get a sense of how difficult, in this chapter we'll compute the fraction of English words that have at least one E. Oh my god. For that, we'll use 4 statements to loop through the letters in a string and the words in a file, and we'll update variables in a loop to count the number of words that contain an E. We'll use the in operator to check whether a letter appears in a word, and you'll learn a programming pattern called a linear search. As an exercise, you'll use these tools to solve a word puzzle called Spelling Bee. Oof. So, loops and strings. In chapter 3, we saw a for loop that uses the range function to display a sequence of numbers. So this entire chapter is essentially going to be all about loops and such. So for I in range 3, print I and space. So when you give it the end argument, you can specify the character that ends in print, which is defaults to the new line character. So whenever you do subsequent prints, it prints on a new line. This version uses the keyword argument end, so the print function puts display. Okay, that's just literally just what I said. We can also use a for loop to display the letters in a string. It's not very helpful, but I'll print it. It's just printing each letter separately. Notice that I can change the name of the variable from I to letter, which provides more information about the value it refers to. The variable defined in a for loop is called the loop variable. Yeah, so basically it is good practice to have the loop variable be named something descriptive that is easy to understand. So for letter in Gatsby, if letter equals E or letter equals small e, print this word has an E. So that's just looping through this letter. Def has E, which is just putting this loop inside of a function. And then def has E. What's the difference between this one and this one? Oh, it's just returning it instead of just printing it, which is like if it is there, return true, else return false. has e word where we replace Gatsby and just add word. This is just basic iterative development of developing the loop you're interested in. So now I can pass in any word to has e and you can check if it has e. Which I believe you can also do like this, and they alluded to this e in ML. If actually wait dot contains dot stir has strip starts with split config capitalized case full center count encode ends with expand tabs find e -1, right? So you could do that and see whatever string you pass in dot find e. So that's just essentially this is jumping up a little bit. Each type generally has some sort of capabilities associated with it. Specifically with strings, I don't think integers have anything. I don't know what that does, but basically certain types can have other capabilities, and you can access those capabilities, those attributes or hidden variables with the dot operator. You'll understand this better once we get into classes and inheritance, but yeah, this is just another way to find string instead of just actively looping over it. Reading the word list. To see how many words contain we'll need a word list. The one we'll use is a list of about 114,000 official crosswords. Following cell downloads the word list. Okay, so we download the word list. The word list is a file called words.txt, which is downloaded in the notebook for this chapter. To read it, we'll use the built-in function open. Yeah, and then you can file object read line aa/n. Notice that the syntax for calling read line is different from functions we've seen so far. That's because that is a method, which is a function associated with an object. So yeah, this is kind of what I was alluding to earlier. In this case, read line is associated with the file object, which we created here with the open function, the dot operator, and the name of the method. The first word is in this list is AA, which is a kind of lava. The sequence /n represents the new line character that separates this word from the next. The file object keeps track of where it is in the file. So if you call readline again, file object keeps track of where it is in the file. So if you call readline again, you get the next word. Yeah, so this is one way to read a file, basically. So if you just keep reading words, you'll just keep getting the next thing again and again, and so you can just loop through the entire line, the entire file. And that way, word equals line.strip. So strip is essentially a function that removes any sort of spaces and things like that at the end and the beginning. That includes /n, which is essentially a new line character, which signifies to the computer like, hey, if you print this and you see /n, don't actually print /n. What you want to do is stop printing on this line and continue to the next line. So strip removes white space characters, including spaces, tabs, and new lines from the beginning and end of the string. You can also use a file object as a part of a for loop. This program reads words.text and prints each word, one per line. Boom, it's just going to go through the entire thing, and it's like giant, and there's a lot, which is fine. Now that we can read the word list, the next step is to count them. For that, we will need the ability to update variables. So as you have discovered, it is legal to make more than one assignment to the same variable. A new assignment makes an existing variable refer to a new value and stop referring to the old value. For example, here's an initial assignment that creates variable x equals 5x, and then you can reassign it x equals 7. So yeah, that's all that is. What these assignment looks like in a state diagram, yeah, so x initially was 5, but now x points to 7, right? And with that, we can we can also update the variable by referring to itself. So in this second assignment, you can see that we're using the same variable on the left and on the right. And on the right, it's basically this expression needs to be evaluated. For this expression to be evaluated, we check the value of x. It's 7. We do 7 plus 1. Then we return from the expression, if you will. And that expression returns a value of 8, which then gets assigned to x. So now x is equal to 8. And if I was to just run this again, it'll be x equals 9, and just keep going recursively that way. Not recursively, but you get what I'm saying. Get current value of x, add 1, and assign that result back to x. That's exactly what this statement is doing over here. If you try to update a variable that doesn't exist, you get an error because Python evaluates the expression on the right before it assigns a value to the variable on the left, right? So you can't do this because you're looking for z before it's created, right? Here it's fine because x was already instantiated before that. Before you can update a variable, you have to initialize it, usually with a simple assignment: z equals 0, z equals z plus 1, right? So boom, that's totally straightforward. Increasing the value of a variable called an increment, decreasing the value is called a decrement. Because these operations are so common, Python provides augmented assignment operators that update a variable more concisely. For example, the plus equals operator increments a variable by the given amount. So z plus equals 2 just takes whatever the value of z is, adds 2 to it, and assigns it back to z. It's as simple as that, right? And there's also similar operators for subtraction and multiplication, looping and counting. So I mean, you guys should probably see this coming now that we have now we know how to increment and decrement and using the same variable, and we also understand how to read the list. It's just all about putting it together now. So we have this simple text, the simple loop that essentially updates total to find out the total number of words. We looped through that. The total number of words is 113,000. Or close to 114,000. A variable like this used to count the number of times something happens is called a counter. Yeah, we can add a second counter to the program to keep track of the number of words that contain an e. So total equals total plus 1. It's just adding to the same loop from before using an additional initialized counter. If has he word, count plus equals 1. And let's see how many words contain e. 76,000. So over half. Essentially, as a percentage of total, like I said, over half, 66%. And that's basically it, how you would do that. What was this thing about? I feel like, yeah, it's just iteration search, just going over loops. I don't know how good this is for people at home, but I feel like for me, I'm just like trying to force myself to go through this book to help other people. So I'm just going to keep pushing through this, and hopefully it's helpful to whoever's watching. Oh wait, no, this we already went through. So the in operator, the version of has he we wrote in this chapter is more complicated than it needs to be. Python provides an operator in that checks whether a character appears in a string. I tried doing that earlier with Emma. Why didn't that work? E in Emma. I guess I must have screwed up earlier because it is working. So yeah, with the in operator, you can just kind of check the existence of something inside of something else, which sounds very wishy-washy, but it'll make more sense once we get introduced to things like lists and stuff. Basically anything that could be considered a collection of things, because a string can be considered a collection of characters, really, can be denoted. You can use that in keyword. So def has e word. If e in word or little e in word, return true, else return false. Honestly, you can make this even simpler by going, oh yeah, here, Or you could also go word dot. Another thing, oh yeah, there you go. They do it right there, lower word dot lower, which then you can just go e in word dot lower, and boom, you're done. See, as they talk about, as they show it right here. So the in operator is a really nice one, and its power really shows up when we start talking about lists and tuples and other iterables and things like that. Search. Based on the simpler version of has-e, let's write a more general function called uses_any that takes a second parameter, that is a string of letters. It returns true if the word uses any of the letters and false otherwise. So this is just has-e uses any, it's just a more generalized version of, other of the has-e function that we had created. The structure of uses_any is similar to has-e, loops through the letters. Okay, I'm not going to read this. This is pretty straightforward stuff. In chapter 4, we used docstring to document a function that explain what it does. It's also possible to use a docstring to test a function. Here's a version of uses_any with a docstring that includes tests. Okay. Each test begins with ... which is used as a prompt in some Python environments to indicate where the user can type code. In a doc test, the prompt is followed by an expression, usually a function call. The following line indicates the value the expression should have in the function if the function works correctly. In the first example, banana uses a, so the result should be true. In the second example, Apple does not use any of XYZ, so the result should be false. To run these tests, we have to import the doctest module and run a function called run docstring examples. To make this function easier to use, I wrote the following function, which takes a function object as an argument. Func, globals, name equals func.name. What is this? How have I not heard about this before? This is actually interesting. Jesus. You have text that look like interactive Python sessions and then executes those sessions to verify that they work exactly as shown. There are several common ways to use doctest. Okay, this is interesting. I'm gonna actually add this to my Trello. My Trello loads. I'm actually just gonna create a new tab group, make it easier. I really need to clean up my tab groups. New tab group with this tab, doc tests. It's actually super helpful. In the second example, Apple does not use any of XYZ, so the result should be false. To run these tests, we have to import the doctest module and run a function. To make this function easier to use, I wrote the following function, which takes a function object as an argument. From doctest, import run docstring examples, run doctests, func, run down, blah, blah, blah. So it takes a function, passes it to this, passes it globals. I don't know what the globals function. Return the dictionary containing the current scope's global variables. Note, updates to this dictionary will affect name lookups in the current global scope and vice versa. The current scope's global variables. So I think that would be just whatever the global variables are in the current scope. That makes sense. And then name equals func dot under name. Not exactly sure why we run this like this, but fair enough. Run doctest uses any. Run doctest is not defined, so I should do this first. Oh, let me do this. Now let me do this. Okay, well, what's going on here? If the result is, then the test passes, otherwise it fails. If all tests pass, run doctest displays no output. In that case, no news is good news. To see what happens when a test fails, here's an incorrect version of uses_any. Oh, okay, interesting. Output includes the example failed, the value of the okay, so this is actually really cool stuff I did not know about doc tests. So That's something I'm definitely going to incorporate, and I am glad I'm doing this because this is just speed running some stuff that like I feel like I should know anyways, but I don't. Honestly. Looking at this glossary, it's beautiful. Exercises. If you use any, you might have noticed that the first return statement is inside the loop and the second is outside. When people first write functions like this, it is a common error to put both return statements inside the loop like this. Ask a virtual assistant what's wrong, because like basically in this particular situation, like semantically, you want to return false only if all the letters have exhausted. So if you do that inside the loop, essentially what happens is that the first time it's false, it returns that. But what we want to do is return false if none of them have it. So yeah. Exercise. Write a function uses none that takes a word and a string of forbidden letters and returns true if the word does not use any of the forbidden letters. Here's an outline of the function that includes 2 talk tests. Fill in the function so if it passes these tests, and add at least 1 more doc test. So yeah, this is good stuff. Totally should do. I'm not gonna do it. Uses only. Write a function called uses only that takes a word and a string of letters and then returns true if the word contains only letters in the string. Here's an outline of that function. Just doing it in docs tests. Write a function called uses all, takes a word and a string of letters and returns true if the word contains all the letters in the string at least once. Here's an outline of the function. Okay. The New York Times publishes spelling bee. For example, the day I wrote this, check word that checks whether a given word is acceptable. It should take as parameters the word to check, a string of 7 available letters, and a string containing the single required letter you can use. Okay. Some sort of arbitrary like spelling bee thing, kind of nice. Good exercise, totally should do it. I'm not going to do it, but you should. Which is easy for me to say, and like it would be actually more fun for me to actually do these. But I'm like I said, I'm just trying to speed run through all of these chapters really quickly. Write a function called score word that takes a word and a string of available letters and returns a score. You can assume that the word is acceptable. Yeah, when all of your functions pass their test, use the following loop to search the word list for acceptable words and add up their scores. Interesting. Okay, so just continuing on with these exercises. Honestly, I'm just gonna start skipping these exercises. Maybe I won't. I'll still skim through them. They're really good exercises, and if you're someone who's learning, who's starting off, I really do recommend this book. It is a good book, and I definitely recommend doing the exercises. They're really good exercises too, and really get you in touch with how to use all of these things. What's really difficult for me is like trying to connect this for someone who has zero context, right? For kids, it's fine. I feel like kids are easier about like, okay, we're playing a new game. What are the rules of the new game, right? But adults are not nearly as good at that. We get set in our ways. Much more importantly, we get anxious and we get stressed and all of that. So it's hard to live in arbitrary land because, you give yourself excuses that it's not useful. And it's, in a very technical sense, yes, true, not useful. But it is useful in that it helps you think, right? All of this stuff, even if you don't do it for computing, for learning this and making money and all that, it'll still help you think, and so it has value in that way. And the capacity to think is, I think, one of the most useful things that any human being can cultivate. So anyways, that's my time today. Thank you all. Have a great one. Bye-bye.